Hello everyone. So today we are going to solve a graph problem of finding the mother vertex. So what is a mother vertex? Mother vertex is a vertex from which we can visit all the vertexes. So mother vertex is a vertex from which we can visit all vertex. So suppose you are given this graph from 0 there is an edge to 4, from 4 there is an edge to 2, and from 1 there is an edge to 0, and there is an edge to 3. So you are given this graph and you need to find the mother vertex. So in this graph, let's start with 3. Is 3 a mother vertex? Can we visit all the vertex if we start from 3? No, we can only visit the vertex 3 if we start from 3. So 3 is not the mother vertex. So 3 is not the mother vertex. How about the vertex 2? From vertex 2, that's the only vertex we can visit. So vertex 2 is also not the mother vertex. How about vertex 1? From vertex 1, we can go to vertex 0. From 0 we can go to 4, from 4 we can go to 2, and from 1 we can go to 3. So we can visit all the vertex from vertex 1. So vertex 1 is the mother vertex. Vertex 0. From 0 we can go to 4, 4 we can go to 2, from 4 we can go to 1, and then 3. So 0 is also the mother vertex. And similarly from vertex 4 we can go to 1, from 1 we can go to 0, and from 4 we can go to 2, and from 1 we can go to 3. So 4 is also the mother vertex. So in this graph we have 3 mother vertex, but we just need to return only one mother vertex. So the input will be given as so you will be given as n, which will be the number of nodes. So in this case it's 5. So n is equal to 5, and then you are given all the edges of the graph, the edge from 0 to 4, the edge from 4 to 2, 4 to 1, 1 to 0, 1 to 3, right? 1 2 3 4 5, 1 2 3 4 5. Yeah, you are given 5 edges of the graph and you need to find the mother vertex. So usually most of the graph problem you can solve using either DFS or BFS. In order to solve this problem, we are going to use the DFS. So what we are going to do is we are going to start the DFS on all the vertex from 0 to n minus 1. So we'll do DFS on vertex 0, vertex 2, vertex 3, and vertex 4, right? So let's say if we are starting the DFS from vertex 3, for example, right? 3 is of course not the mother vertex. So when we start the DFS from vertex 3, what we are going to do is we will mark 3 as visited, and there are no more edges we can visit from 3. So our DFS will return. Then we start DFS from vertex 2. We check whether vertex 2 is visited or not. Vertex 2 is not visited. So we'll start from DFS from vertex 2 and we'll mark vertex 2 as visited. There are no other vertex that we can visit from vertex 2. So our DFS call will return. Then we'll start DFS from vertex 1. When we start DFS from vertex 1, it will visit all the vertex and it will mark all of them visited. So in the outer for loop, when we are doing all this DFS, when we go and check that whether 0 is visited or not, in order to start the DFS from vertex 0, it will already be visited. Vertex 4 will also be visited. All the vertex will be visited. So the thing is, when we have done the DFS from the mother vertex, all the vertexes are visited at that point. After that there are none of the vertex that are left to be visited. So that is the mother vertex. So what we are going to do is, so we will have a for loop. So let's see, just give me one sec. Okay, so we are going to have a for loop from 0 to n minus 1, and we're gonna check if this vertex is not visited, vertex I is not visited, then we're gonna start a DFS on vertex I. When this call return, we will have a variable integer variable mother vertex. And we're gonna set it to maybe 0, and then here we're gonna set mother vertex to I. So that's what we are going to do. So this is a for loop, and this is the if condition. So once we have done the DFS on the mother vertex, we will never go, when we go back in this for loop, we will not find any vertex which is not visited. So this variable mother vertex will have the vertex which is a real mother vertex. After we are done with this, we will do one final DFS on mother vertex. We'll reset the visited array to false, and then we will do final DFS on mother vertex, and then we're gonna check to see that if all the vertexes are visited, are truly visited from this mother vertex, and then we're gonna return this mother vertex. So at the end we're gonna return mother vertex. I'm going to write the full code for this. So what is the time complexity for this one? So here, since we are doing a DFS, the time complexity for DFS is O of V plus E, right? We are visiting all the vertices and all the edges, but we are doing it only once, right? If the vertex is visited, then we are not going to visit that vertex or that edge again. So the time complexity for DFS is O of V plus E. Same thing here also, it's O of V plus E. So that is our time complexity. What is the space complexity? So in DFS, we are declaring a visited array which will be number of nodes. So that is O of V for visited array. And for the recursive call stack, because we are making a recursive call in the DFS function, so that is also O of V. So the space complexity is O of V. This DFS call, it's called in the for loop, inside the for loop. But remember that when this DFS call visit the vertices and the edges, it never repeats. If the vertex is visited, it's not going to visit that vertex or the edge again. That's why the overall time complexity of this whole thing is V plus E. Okay, so now let's go and write the code. I'll just go ahead and write the code here for this for finding the mother vertex. Just give me one sec. Okay. So here is my function public. The return, it's returning integer. So public integer find mother vertex. The argument to the function is number of nodes, and array list of array list of integer for the edges. Okay, so that's my function. So what I'm going to do is, first I need to construct a graph from these edges. So let's construct a graph. Let me construct a graph. Okay, so I'm going to have a public integer vertex, which will hold the vertex for the graph, the number of vertex for the graph. Then I'm going to have public. So I'm going to construct a graph using the array of array list. So we'll have an array for the nodes 0 to n minus 1, and for each array position it will hold all its neighbor in the array list. So it will be something like this. So for example, node 0, if it has neighbor 1 and 2, so it will hold like this. This is the array, and the array holds the array list. So it's an array of array list. For example, node 3, it has neighbor 4 and 5, so something like this. So this will be array list of integer, array of array list. That will be my graph. Then I'm gonna initialize my graph. Initialize graph. I'll pass an argument which is the number of nodes. So here the vertex will be equal to n, and graph will be equal to new array list. The size of array is n, right? And for integer I is equal to 0, I less than n, I plus plus, I'm going to graph of I. So this is the array. So graph of I is equal to new array list. I don't know the neighbors yet, but I know that these are all the vertices from 0 to n minus 1. We have all, those are all the vertices that we have in our graph. So that is the initialized graph. Now I'm going to write a method for adding the edge. So add edge, it will take the start vertex and the end vertex. Now since this is a directed graph, so we cannot do graph of start, so the array at the start position, and it's an array list, so we have to use add end. So the end is the neighbor, right? So now we have constructed our graph. So this is the function that we are given. So what we're gonna do is we're gonna initialize the graph, we're gonna pass the number of nodes, and we're gonna add the edges. So we're gonna iterate through this array list of array list, and we're gonna get the edge, which is like if there is an edge from 0 to 4, then this array list will have 0 and 4. So edge will have 0 and 4. And then I'm gonna add edge. What is my start? Edge dot get 0 and edge dot get 1. So that's my start and that's my end. Once I have initialized the graph, I'm going to do the DFS. So for DFS, I need a visited array. So I'm going to declare boolean visited, and the size of that array is n. And what else I need for DFS? I think that's all I need, right? And I need to do a DFS in the outer loop. So for we need to do DFS for all the vertices. So for integer I is equal to 0, I less than n, I plus plus. I forgot to show you one more thing. What if the graph doesn't have a mother vertex and there's no vertex from which you can visit all the vertexes? In that case, you need to return -1. So we are going to initialize our mother vertex variable with -1. So if there's no mother vertex, then we are going to return -1. And then now we're gonna check if it's not visited. If that vertex is not visited, we are going to start DFS on that vertex. So we are going to start DFS on vertex I. We need to pass the visited boolean array. What else we need to pass? Yeah, that's it. And then we need to set our mother vertex to I. Right? Remember, once the mother vertex, if it's really this I is really a mother vertex, then it will never go again in the for loop, and it will never go inside this if condition, because all the vertices from that point onwards are visited. So that is our mother vertex, right? And once you find the mother vertex, you need to reset this visited array, and you just need to do one final DFS to check that this is really a mother vertex that we have found. So let's reset this visited array with false. So we are resetting that, and then we are going to do one final DFS on this mother vertex. So we are going to do DFS on mother vertex, and we are going to pass the visited, and then we are going to iterate this visited array, and we'll see if there is any vertex which is not set to true. That means it's not visited, and that means that this is not a mother vertex that we have found. So we're going to iterate through visited array, and we are going to check if visited of I is false. So if visited of I is if it's not visited, so if we have any vertex which is not visited, then we need to set mother vertex to -1. We can break this because we found one vertex that has not been visited, and we can return the mother vertex at the end. Right, so that's our main function. Now let's write the DFS. DFS is very simple function in graph. The same DFS function you can reuse again and again. So public void DFS, this is your start node from which you are starting your DFS. Boolean visited. So first you need to mark your start node as visited. So visited of start is equal to true. Then you need to go iterate over all the neighbors of that start node. So for integer, these are all the neighbors of the start node. So graph of start, right? It will give you the array list, and these are all the neighbors. Now if the neighbor is not visited, right, if the neighbor is not visited, then you are going to I need to remove this S. If the neighbor is not visited, then you are going to make a recursive call to the DFS. That is, you are going to start DFS from that neighbor. So you are going to start DFS on that neighbor, and you need to pass the visited array. That's it. Only 2 lines of code for the DFS. That's it. So this is the code for finding the mother vertex. It's a very simple code, as you can see. You create a graph, you do you iterate for all the nodes, and you do the DFS. You find the mother vertex, you double verify it whether it's really a mother vertex, and this is your DFS function. So that's it. And as I told, the time complexity, so TC for doing the DFS is number of vertices plus number of edges, and the space complexity in this case is O of V. So that's the time complexity and space complexity. Thank you so much for watching the video, and I'll come with some more videos on graphs, and thank you so much.